In this section, we look at finding confidence intervals for the variance and standard deviation. For these, we use the chi-squared distribution, which is in our table A4. Here's a diagram, along with a few properties of the chi-squared distribution. Note, when reading the table values in A4, the critical values have corresponding areas to the right. The sample variance is the best point estimate for the population variance since it is unbiased. We construct a confidence interval to estimate the population variance or standard deviation. Since the chi-squared distribution is not symmetric, we need to find two values, the chi-squared left and chi-squared right critical value. Here are the requirements along with the formula for finding the confidence interval for the variance or standard deviation. Here's the procedure for constructing the confidence interval for variance or standard deviation. Let's do an example for finding the critical values on the chi-squared distribution. Example A, we want 95% confidence, so alpha is 0.05 and alpha over 2 is 0.025. Degrees of freedom is 19, so we want the area to be 0.975 and 0.025 when finding the chi-squared critical values. Now we look on the table, A4, to find these values with degrees of freedom, 19. Highlighting where the area is 0.975 and 0.025 to the right of the critical values. We get the left chi-square critical value being 8.907. And the right chi-square critical value being 32.852. Now we look at B. Degrees of freedom is 50. Alpha is 0.10 since we want 90% confidence level. And left chi-square critical value is going to have a right tail area of 0.95, and right chi-square critical value is going to have 0.05 right area. Now let's look on the table to find those values. Highlighting the areas corresponding to the critical values. We get 34.764 as the left chi-square critical value. And for the right chi-square critical value, we get 67.505. Example 2. Here we want a 95% confidence level for the standard deviation of speeds of ticketed drivers. Alpha is 0.05 and degrees of freedom is 24. So finding the critical values on the table, highlighting the corresponding areas to the critical values. We get the left chi-square critical value of 12.401. And we get the right critical value of 39.364. Now we just need to square the standard deviation. plugging in our information into our formula here. Now we input the information into the calculator and evaluate. And we have our confidence interval for the standard deviation. So we are 95% confident that the true standard deviation of speeds of drivers ticketed is between 1.8 and 3.2 miles per hour. Next example. Here we want to find a 99% confidence interval for standard deviation of reaction times of NASCAR drivers. So alpha is 0.01, degrees of freedom is 7, and sample variance is 0.144. Now we just need the chi-squared critical values. Highlighting the corresponding areas on the table. We get the left and right critical values of 0.989 and 20.278. Now we just plug in and evaluate. And here is our confidence interval for the standard deviation of NASCAR drivers' reaction times. So 99% confident that the true standard deviation of reaction times for NASCAR drivers is between 0.07 and 0.32 seconds.